My name is Bruno Simic. I don't know this guy here because my name is not properly written here and is in Croatia. Even Germans can write it properly, but not here in Split. Sorry. Yeah. And thank you for taking your time for this last presentation. Sometimes it's good to be last or sugar at the end, like Ivan said today. I'm going to talk about future-proof databases. So I'm part of a Couchbase team, and Couchbase is an open-source database. It's a distributed. It's somebody says it's no SQL. I said it's new SQL, and there are a few reasons you will see today. Why? The biggest problem what we have today is 24 minutes. So don't expect too technical presentation. And let's start basically with it. So who is using Couchbase now actively? OK, so you see those guys here? Talk with them. Take Couchbase. That's it. Thanks. Just a joke. So talking about the databases and the future of something, you need to know the past. So if you think about how the database business was developed, the first one was in 1960. It was IBM Sabre as a first commercial use of a database. It was an airline booking system, which exists today. It's not the same one, of course. It's a modern one, but by the way, they're also using Couchbase now for this. Then in 1979, we have the first commercial usage of Oracle, version 2. Then we had in 2007, Google and Amazon, almost same time, almost simultaneously. There was a big table of Google and Amazon Dynamo papers published. So, and this was the concept, sort of Cassandra, which came a year later in 2008, together with Mongo, with Redis, and all those other NoSQL databases. And why we have here Couchbase in 2011, and why is it important? Because Couchbase is the first NoSQL database not following the old principle of old server system like master-slave, and following the completely new distributed database setup. So Couchbase is a merge of two different technologies. It's a memcached as a caching layer, and CouchDB as a key value and database storage. And this is the power of distributed system with memory first or caching system, which is very fast. So talking about today experience, so we saw what is actually the past. And we saw that the world is changing very fast. So basically, from 1960 to 2008, it was a huge development. But what happened actually the last few years? It was sublimation of everything in 8 years, more or less. So what we have today is a shift of expectation. So 20 years ago, nobody was thinking about mobile phones, or that you would have actually the power of a personal computer on your mobile phone. And today, we have the digital experience that should be personalized. So it means that you expect that something is based on your previous experience, so somebody is monitoring you. Then we have a system which is feature-rich. So it means if you have an online shop, and you cannot just present a picture of a product. You won't need a video, you need a 3D model, or whatever. So you want to go deeper into this element that you, or product that you want to buy, for instance. It has to be fast. Nobody wants to wait today. So years ago, I'm a little bit older, so I know that with the modems, you had to wait for ages for something to load. Today, I'm leaving the page, actually, if it's not loading fast. So anywhere. So you can go to the beach here and read your newspaper online. Imagine this for years. 5G is coming, so it would be even faster, and and even more distant from the, let's say, cities or whatever. And anytime. What does it mean, anytime? High availability. You don't have time to take down your systems anymore, because everybody wants to have it 24/7 with zero downtime. And what is basically the cost of a poor experience today? It is, you can measure it, and you can measure it by percentage. So 91% are not going to do any business with your company again if they have a poor experience. And almost 90% will leave for your competition if there is any, and there is a competition. So this should be a problem for you. And then a question is, what makes databases so important? So who knows it? It is the data provider for your application. So what the database is doing, they are basically pushing the persistency of the application to the background level. And that's it. So that's why a database is important, and even more important than you may think about this. So we are talking a lot about DevOps. DevOps is not a nice term, but in my opinion, from my database perspective, DevOps is very suitable for applications. You cannot do this or you cannot apply it for databases. Why not? Because the expectation that a developer have are totally different from expectation that operations have it. And I'm going to show you this. So first of all, if you're a developer, you need lots of tools. You need a system which works on your laptop, which would work on any single cloud, which may work also on mobile devices, because you want to develop, let's say, a system for mobile phones, mobile phone apps that have online and offline capability. You need, or you expect, a good support from community, because lots of people, like the developers, developing the same stuff would have maybe a similar problem, and would have the solutions for this. Then you need something that supports easy and agile development. So you can, if you have, let's say, a change, you don't want to do 2 weeks of waiting for somebody to be able to do this change. For instance, relational database model, DBA, who only have right to change the database structure. You need lots of frameworks and SDKs. Today you are programming in Python, tomorrow, or Java. Tomorrow you may start with Go. What is also important today, lots of companies or lots of projects starting microservices. So you need a system which would support something like this, even if it's just a REST API interface. You have, or you expect, lots of documentation. You expect a system that is secure by nature. So, and you expect, even if you talk about open source, professional system that would support you like professional training. So the documentation itself, it's not enough. Now, what is actually operations expecting? So those are guys who are driving this. And we had a nice talk with, from Yolanda before about Kubernetes. Kubernetes is a nice tool for applications. But Kubernetes is something that is having a big problem with databases, which we solve as a Couchbase, because we have solutions for this. But generally, it's a big problem. Why? Because Kubernetes or containers are stateless, more or less. So how do you do a system which is actually stateless and make it stateful? This is the challenge with this. And the operations have some different expectations. So operations expect a system which is always on and zero down. Why this? You as a developer, you have your local database. You can shut it down and start it all the time. If you have operations and you have 2.5 million operations per second, and these operations are bringing money, 15 minutes of stop can cost you 4.7 million euros. We have a customer like this. And it was not our fault, but it was lots of money for system not working. Any cloud, any device. this is something that is very similar to developers. Why this? Because today you may start on-prem. Tomorrow you are virtualized. In a few months you may have a Kubernetes system on this. And you don't need to do any kind of migration. You just port your system to something that is existing. Global distribution. How many companies start in, let's say, in Europe, and then have a second or third business somewhere in Australia or in USA? So you cannot serve those customers using data center in Europe. You have to have a distributed system. So how are you going to distribute a database to different continents? It's not easy, but it's possible. You need a system that is self-repairing. Why this? Because if it's gone, you're not serving your customers. You're losing money. So what is the way to prevent this? To have some kind of automation which is give you the possibility to run the system even on a lower performance, but you still can reach your customers. Easy maintenance, cost reducing, scalability is one big topic for everybody. So when you start today and you have, let's say, 1 terabyte database, what are you going to do if you have 10 terabyte database tomorrow? How many times you have to stop your service to add new memory, add new hard disk, add new CPU or whatever? And of course, it has to be secure and it has to be too high performance. So you see, expectations are very different between those systems. And now, where to start? We heard Kai's, my good friend, talk today. There is a DB Engines, and DB Engines list today, a few days ago, 347 databases. And 137 databases are relational databases. So there is some other kind of database today on the market. And this is NoSQL database. So what is the problem with the relational database? Scaling. Scaling is hard. So you can scale a relational database up to a certain level. But what is your ceiling? It's mostly the hardware that you can use. So I'm a kind of 90s, and the tables are kind of 90s. But it doesn't mean that I'm not going to work today. So even now, the tables are, let's say, very good system. A relational database system is very good for certain kind of application. The best, for example, one of the things that you should not do with a distributed database system is accounting in an isolated transaction. So basically, you have, let's say, a banking system where you have one account where you deduct money and one account that you put money on in a closed environment. It's not something that you can do with a NoSQL database. This is ideal world for relational databases. But think about what happened after this transaction is done. The very microsecond after transaction is done. It's history. So what are you going to do? Are you going to keep it? No. Why should you keep those transactional records which are history? So you have one account that is deducted, you have one account that's added. So what you need to provide for your customer is a account list or balance. So when you provide this, when the transaction is done, you just transfer those data easily in the background by using, let's say, Kafka or some other streaming method. And you have, on one side, the possibility to scale. On the other side, you keep your possibility to do transaction over different, let's say, operations. And then the question is not about if relational databases can hold big data. We are talking about big data today and fast data. It's only the question, how much can it cost? Because relational database can only scale up and not out, and it's expensive. And what is the future, actually? The future is very denormalized. It is, I would say, an aggregation system. So instead of using a lots of tables, you can use a lots of objects. To be honest, how are you doing your programming today? It's object programming. So what you're doing, if you're using relational database, you take 10 tables, join them, make an object, put some changes in this object, and write it back by using 10 relational tables. So is it efficient? Not really. So what is the way to do this, or better way to do this? Using Json, for instance. It's an object. So if you need something from this object, or if you need a complete object, you have only one read. You don't have to do any join. So that is the best and the easiest way and the best performant way to do this. The second benefit of using objects is you can move those objects from the edge device, from mobile device, to the central database without losing the entities within this object. You cannot do this with the relational databases. If you have, let's say, 2 terabyte database and you need just a portion of this data on a mobile device, how are you going to keep all those relations in, let's say, 200 tables? It's almost impossible. So if you need a subset of a relational database, it's hard, almost impossible. If you need a subset of a NoSQL database, a JSON object, it's a very easy task. And we see here now in this example, sorry, this side, how actually, or what is the difference between relational database model and JSON document. And now you will say, yeah, but normalized, it means it is less memory, less disk, less something. Yeah, it's true, but what is more? It is more time. And if you have to put weight on what is more important today, is it the memory or is it the time? So memory is cheap today, but time is not. If you're not providing your data fast enough, then you're losing. And like I said, memory is cheap. And those concepts that we had with the relational database tables are not suitable for big and fast data we need today. And the best way is, we are still thinking relational. So, even with a relational, even with a JSON document, with an object, you will still think in relations. So, it is my car, it is my laptop, it is my boat, my house. Those objects always have the relation to something. And you as developer, you don't want to lose these relations, right? So it's not about just getting lots of key values, merging them somewhere in the background. It is much easier. Use the technology you know for decades. It's a simple SQL. But it's also simplifying the whole structure. Because on one side, you have the ability to use simple, very, very easy structured objects without need to make lots of relations. On the other side, you can still match these relations by using SQL. And now, the commercial aspects. We heard today from Kai, open source is important. Of course, it is great. But when you start a project, you start using open source. But what are you going to do when you start earning money with this? You need somebody who's going to take support, who's going to take care about bugs. So somebody who is providing open source as an enterprise feature. There are lots of companies that force actually their departments to use some kind of contracts, even with open source vendors. So if you take an open source vendor, which is not having this kind of possibility to support you, then you may actually not have a success with your product. The third part, which is also important, is we have now lots of cloud provider database as a service. It's very dangerous because you're using sort of open source, but you're using infrastructure vendor lock. It is easy to come in. It costs nothing. But when you have to go out. Check with Amazon AWS. What are you paying per million transaction or gigabyte of data to go out? It's not cheap. And secure your investment. Why this? If you cannot scale, if you have to change your technology after a year, 2 or 3 years, then you have to start again. It could be very, very costly. So, when you think about database and scaling up and down, there are some questions that you have to ask. So, how easy is to add or remove node or server, whatever? Which is the price of it? Do I have to stop the system? Can I do this during the runtime of my database? Can I handle 10 times more data than projected? Why this? You will see an example in a few seconds. Is there a single point of failure? The best system you can have is nothing worth if you have a single point of failure. If it's gone, your system is not working. And can I replicate the data from the edge and back? Why this? Because today, we have something like 20 billion of IoTs. How many mobile devices? I don't know. And what is going to happen in 5 years? Maybe everybody would just have the mobile phones and do everything on a mobile phone. So you need something to bring the data back to the central system.
Look at this. There's a Vaporeon on that spawn right there, so everyone's running.
There's a what there? You tell me you're recording.
There's a Vaporeon.
That's funny. Oh my god, I don't even know.
Oh my god. Everyone's just, well.
So you know what is it? Pokemon Go. Yes, this was the traffic jam in New York Central Park that was actually started as somebody spotted something that was very rare. So, and why I'm showing this? Because Pokemon Go was the first, let's say, big success of Couchbase. Think about a company growing from 0 to 28.5 million users within 1 month. They were earning 2007 million in this first month. They're still earning 68 millions per month in 2019. And they were a part of the database that they had was Couchbase. They were adding more than 10 nodes every single day to be able to cover the need for users. This would not be possible with a normal, let's say, relational database. No way. And this is the reason why companies like Viber use Couchbase, like Amadeus. 75% of all flights booked worldwide is Couchbase. 95% because 75 is Amadeus, 20% is Sabre. We have some big customers using Couchbase, but you don't know this. Why? Because you don't see what kind of database it's hidden behind the website or graphic user interface or app. So, the revenue is important for you. If you choose the right system, you're going to earn money. And if you choose the system where you cannot grow, you're going to lose money. So, think about when you select a database. You can build a great database, or you can build a great application, but if you have a bottleneck in your database, this application is not growing. So you just end with the same bottlenecks that you had before. And you have to think big and fast. But it's not only about one single system. So it is the wise man, Jeff Bezos, said, the right tool for the right job saves money and gets your products to market faster. So it's not only about Couchbase, it's not only about MariaDB, and not only open source. It's your product, it's your use case. Think wise what you're going to apply. And if you want to connect with me, I'm just on a LinkedIn. You can also get in touch with me here, or you can buy me a beer today. Just try to install Couchbase, use it. It's open source, it's free. So if you need any question or any help, just ping me. Thank you very much.